Example 3, simplify. This time here you see you have some quotients of two expressions, so fractions actually. So let's start with the first one. 6 to the power of n over 3 to the power of n. It helps in these problems to look at the base of each power and try to express it using prime numbers. So for example, number 6 here can be expressed as 2 times 3, as a product of two prime numbers. Let me do it. So I will exchange or replace 6 by 2 times 3 and all to the power of n divided by 3 to the power of n. There is no change in this second factor in the denominator, and the reason for that is that number 3 itself is a prime, so you cannot do anything with this. Now, there is a power law which says that AB to the power of n equals a to the power of n times b to the power of n. You are familiar with this one. So if you identify what a and b is in the numerator, you can use it. A is 2, b must be 3. So this fraction can be replaced by 2 to the power of n times 3 to the power of n, and all that divided by 3 to the power of n. And you see the numerator and the denominator now, they have a common factor, 3 to the power of n. And what you should understand is the fact that 3 to the power of n is actually 1 times 3 to the power of n. Okay, it's just one piece, one lot of 3 to the power of n. So what you now do is you can cancel this and this, since this is a common factor, and you arrive at 2 to the power of n divided by 1, which can be then replaced by simple 2 to the power of n. And this should be the correct answer, and really it is. Now, in part B, we have another fraction. We have 4 to the power of n divided by 6 to the power of n. Let us apply the same strategy of replacing bases by product of prime numbers, whatever it might be. So number 4 here is 2 to the power of n. Well, it's 2 times 2 actually, okay, 2 times 2 to the power of n, and 6 here is 2 times 3, 2 times 3, all to the power of n. Now we can use this power law outlined here, so it's 2 to the power of n times 2 to the power of n in the numerator divided by 2 to the power of n times 3 to the power of n. Now there is a common factor which can be cancelled out like this, and you arrive at 2 to the power of n divided by 3 to the power of n. Well, you could leave it as it is, but there is another law, power law, that you can use here at this moment, and it's the law a over b to the power of n. You see that these two powers have the same exponent, okay? So it's like a to the power of n divided by b to the power of n. So we start here on the right hand side. This is our situation, 2 to the power of n divided by 3 to the power of n, and we should end up here. So this should be the same as 2/3 to the power of n, and this might be considered the final answer to this problem.